Hi, this is Wendy Lightheart, and in this lesson we're going to take a look at variables, algebraic expressions, and equations. In algebra, we use letters such as x and y to represent numbers. If a letter is used to represent various possible numbers, it is called a variable. So for example, the variable x might represent the price in dollars for 1 gallon of paint. Suppose you need to purchase 5 gallons of paint. Then it will cost you 5 times the cost of 1 gallon of paint, so that would be 5 times x, or 5x, dollars to purchase 5 gallons of paint. A combination of variables and numbers, the operations of addition, subtraction, multiplication, or division, as well as powers or roots, is called an algebraic expression. So for example, this is an algebraic expression. We have 5 times x minus 2 times the expression x plus 3 being raised to the 4th power, divided by 6. So notice we have a combination of numbers and variables. We also have addition, subtraction, multiplication, division, and even a power in this algebraic expression. So we're going to want to be able to write algebraic expressions for an English word or phrase. So in order to do that, we need to take a look at the common words or phrases that we use in English that represent mathematical operations. So for example, the word sum, or the word plus, the phrase increased by, and the phrase more than, all indicate the mathematical operation of addition. And then the word difference, minus, the phrase decreased by, or the phrase less than, all indicate the mathematical operation of subtraction. Next we have the word product, the word times, and then if you have a fraction or a percent preceding the word of, or the word twice or triple, those would all indicate the mathematical operation of multiplication. Next we have the word quotient, the word divide, the word per, and the word ratio. And all of those words in English represent the mathematical operation of division. You might take a moment to pause the video and write these down so that it can help you with the rest of our problems we're going to be working on. So now let's translate some algebraic expressions into many different English phrases that we could use to represent that same algebraic expression. So first, how about the expression x plus 5? So think about all the different words and phrases we can use to denote addition. So we could say that this is the sum of a number and 5. So we don't know what number x is, so we'll just call it a number. We could also say this is a number plus 5, a number increased by 5, or 5 more than a number. All of those would represent the algebraic expression x plus 5. Here's another one, x minus 7. So here we have subtraction, so think of all the different words and phrases that we can use for subtraction. So we could say that this is the difference of a number and 7, a number minus 7, a number decreased by 7, or 7 less than a number. Notice that we have the order is reversed on the last phrase here, 7 less than a number, because it would be incorrect to say a number less than 7 when it's really the 7 that's being subtracted from the x. Okay, how about 2 times x? an English phrase to represent 2 times x, we could say the product of 2 and a number, or we could say 2 times a number, or twice a number. We wouldn't use the word of in this case because the 2 is not a percent or a fraction. Here's our last one, x over 3 or x divided by 3. We could say that this is the quotient of a number and 3, or a number divided by 3, a number per 3, or the ratio of a number to 3. Okay, so let's review the order of operations so that we can look at some a little bit more complicated algebraic expressions. So recall the order of operations. Some people like to use the phrase, "Please excuse my dear Aunt Sally," to help them remember the order. And the P, remember, represents parentheses. So that tells us to first perform all the operations that are inside parentheses or brackets, above and below all fraction bars, and inside any other grouping type symbols. Next we have E, which stands for exponents. So if you have any exponents in your expression, you would need to perform them next. Then you would perform the multiplication and division in order from left to right. So even though in the "Please excuse my dear Aunt Sally," the M comes before the D, we don't necessarily do multiplication before division. It depends on the order. So we perform them, whatever comes first, as we move from left to right. And the same thing for addition and subtraction. We perform all the addition and subtraction in order as we move from left to right. Okay, so let's write an English phrase as an algebraic expression, and we're going to let x represent the number. So our English phrase that we have here is 4 more than 5 times a number. So we want to write an algebraic expression that says the same thing. So we need to think about the keywords that represent the different mathematical operations, but we also need to think about the order of operations. So let me show you how this works. So first of all, if you look back at your table of your English phrases and what operations they represent, we can use that and then the order of operations, and we see that more than, remember, was addition, and the word times meant multiplication. Now if you look at the order of operations, since multiplication is before addition, we do the translation of the multiplication part first. So we would first translate the 5 times a number into 5 times x. And in algebra, if we have a number times a variable, we don't need that multiplication symbol, so we would simplify that to 5x. Then the phrase 4 more than means that we add 4 to what we already have, which is 5x. So that gives us the algebraic expression 5x plus 4. Let's try another one. So the English phrase for this one is 14 less than the quotient of 2 and a number. So first notice that less than is subtraction. And remember that quotient represents the operation of division. And since division is before subtraction, we first translate the quotient of 2 and a number into 2 divided by x, and we usually in algebra would write that with a fraction bar. We rarely use that division symbol that you learned in elementary school. So we would write that as 2 and then a fraction bar over x. Then the phrase 14 less than means that we're subtracting 14 from what we have so far, which is 2 over x. So that gives us 2 over x minus 14. And remember, you have to be careful of the order. If you wrote 14 minus 2 over x, that would not be correct. So be really careful of the order when you're working with subtraction. Then here's our next phrase, 1/4 of a number decreased by 10. So notice we have the word of, and it is preceded by a fraction of 1/4. So that word of would translate to multiplication in that case. And then we also have the phrase decreased by, which remember represents subtraction. And since multiplication comes before subtraction, we would first translate the 1/4 of a number part of our phrase into 1/4 times x, and we would write that as 1/4 x, just dropping that multiplication symbol. Then the phrase decreased by 10 means that we subtract 10 from what we have so far, which is 1/4 x, and that gives us 1/4 x minus 10. So now we'll look at evaluating algebraic expressions. To evaluate an algebraic expression means to replace all the variables for the given values and use the operations to simplify the expression to a single number. So let's see how this works. We want to evaluate the expression for this indicated value. So the expression here is 2x minus 7, and the indicated value here after the semicolon is 5. So this is asking us to evaluate the expression 2x minus 7 when x is equal to 5. So we start by replacing the x with 5. So that would look like that. And it's 2 times 5 is what the 2x means, is 2 times x. So we have 2 times 5 minus 7. And now we need to perform all the operations using the order of operations to simplify this down to a single number. So we first would multiply that 5 times 2, which would give us 10, and then we would subtract the 7, which would give us 3. So the single number that this simplifies down to when x is 5 is the number 3. So this is the process of evaluating an algebraic expression. So now let's take a look at algebraic equations. An equation is a statement that two algebraic expressions are equal. An equation always contains the equality symbol, that equal sign. So if you see an equal sign, that's your clue that it's an equation. So some examples of equations are 7x minus 8 equals 24, or 9x plus 13 equals 4x, or 5 times z minus 2 equals 6 times z plus 1. So notice those are all saying that one algebraic expression is equal to another. That's what an equation is. So let's write an English sentence into an algebraic equation. So we're going to let x represent the number again. But now we have a sentence instead of a phrase. So our sentence is 4 more than 5 times a number is 42. So we're going to treat this just like we did with the phrases, except for now we have that equal sign to worry about. So notice we have more than, which means addition. And we have the word times, which means multiplication. And we also have that word is, which remember is going to be our equal sign. So since multiplication is before addition, we first translate the 5 times a number into 5 times x, which simplifies to 5x. Then the phrase 4 more than means that we're going to add 4 to the 5x, giving us 5x plus 4. And then lastly, we replace the is 42 part of our sentence with equals 42. So we obtain the equation 5x plus 4 equals 42.